Assalamualaikum. Here is one new lecture, polymer blends. The major problem in the application of polymer in engineering is their low stiffness and strength. When compared to the metals, the moduli are 100 times lower and the strength जो है वो उनकी 5 times जो है lower होती है. So that's why the homopolymer had the moduli of 0.3 and 20 and strength is 12 to 140 m square. Similarly, steel and aluminium also have their specific moduli. What is the community of the plastics? The big four commodity thermoplastics PE, PP, PVC, and the PS. More than 85% by volume of the world plastic consumption belongs to the big four plastics. And now, engineering polymers. The polymers that are used in the manufacture of the premium plastic products where high temperature resistance, high impact strength, chemical resistance, and other special properties. These are the requirements. Now, what is the engineering polymers? Engineering polymers are basically the plastics, aliphatic polyamides, nylon 6, nylon 66, ABS resins, polycarbonates, polysulfones, polyphenylene oxides, and polyacetals, and engineering polyesters, and the fluoroplastics. Now, what is the method to increase the stiffness and the strength? Noble homopolymer design, crystallization, cross-linking, copolymerization, radiation, and similarly IPN, interpenetrating network sources, polymer blends and alloys, and the reinforced polymer. So you can say that polymer blending is basically increase the stiffness and the strength of the polymer. Now, what is the polymer blend? Polymer blending may be caused to reduce the cost of an expensive engineering thermoplastic, to improve the processability of a high temperature or heat resistant thermoplastic, and to improve the impact resistance. What is the blending mixability? Commercial blends may be homogeneous, phase separated, and a bit of both. And for this type of polymer blends, homogeneous or phase separated will depend upon the many factors such as kinetics of the mixing process, processing temperature, presence of the solvent or the other additives, and however the primary consideration for the determination of mixability of the two polymers is basically thermodynamic issues that is governed by the Gibbs free energy consideration thermodynamically. Now, thermodynamical equation is delta Gm equal to delta Hm minus T into delta S. Gibbs free energy. Gibbs free energy Gm is positive at the given temperature. Polymer is the blend, will separate into phases, and for complete mixability, two considerations are necessary. Must be negative, just like Gm. Second derivation of which derived the volume fraction of the component, which must be greater than 0. Volume factor means delta Gm, and similarly their fraction component, volume fraction component, should be greater than 0. But in our general life, polymer blend which will separate at the equilibrium into two mixed compositions which can exhibit a wide range of phase behaviors, including upper and the lower critical solution temperatures. And here is a pic of the idealized phase diagram for a polymer blend, in which you can say with the temperature and phase volume graphical representation, and the range of phase at including the upper and lower critical solution temperature. Two phases जो है वो exist करती हैं, coexist, and blend is mixable at all the components. It means that there is basically is the combination. Now, LC-ST behavior is quite common for the polymer blends compared to UCTS behavior, and LC-ST is equal to 240 degrees centigrade, and this means if the blend is melt processed above 240 degrees centigrade, phase separation occur, and UCST behavior may be observed only in a solution which is a low molecular weight and lower molecular weight solvent in which used. Recently, interest in the blends containing three-component polymer. It means ternary blend name appeared that three-component system polymer, and PMMA and PEMA polystyrene co-acetonitrotyl SAN. SAN is compatible with the PMMA and PEMA. but PMMA and PEMA are immiscible. They are not mixed. Commercial polymers, example of mixable polymer blend, polymer 1 PS, polymer 2 polymethyl vinyl ether, and similarly PVC and PCl, nitrile rubber, PVF, polynitrile fluoride, and PEMA and PMMA. And what is the properties of the blend? Properties of a mixable polymer blends can be intermediate between those of an individual component, additive behavior, and in other cases, blend properties may exhibit either positive or the negative deviation from the additivity. And what is the compatibilizers? Mechanical properties of immiscible blends are often poor due to the inadequate interfacial strand between the dispersed phase and matrices and additive to the promote the mixability by reducing the interfacial tension, which are called as the compatibilizers. And the reality is reactivity of the compatibilizers. They chemically react with blend components, and non-reactive compatibilizers are basically block or graph copolymers of the blend homopolymers. What is the penetrating network? IPNS. IPNS are combination of the two or more polymer in a network form, and IPNS include the UV, PUS, PS, PEA, and PMMA. These are basically polymers. Okay. Earliest commercialization IPNS used basically automotive application consists of PP and EPDM, ethylene propylene diamine terpolymers. What is the sequential IPN? You can see here the sequential IPN, ethyl acrylate and the tetraethylene glycol dimethyl acrylate when combined, and AIBN PEA network is formed and swollen with the styrene plus DVD, and PEA network is again reacted with the styrene and the divinyl benzene, and catalyst is AIBN, and heating PEA and PSIPN network is formed. If no networking agent is used for second polymer in the formation of the sequential IPN, then semi-IPN single network of the initial polymer will be formed and polymerizing the second monomer before the equilibrium sorption occurs and the gradient IPN. When the both polymers are synthesized and the cross-linking simultaneously, then IPN and same first second polymer step polymerization other and the chain polymer, and to eliminate the co-polymerization. These are formed. And what is IPN structure, which are used for soft contact lenses, ion exchange resins, pressure sensitive adhesives, controlled release of drugs, and the preparation of a novel membranes. What is reinforced polymers? Polymer composites, commercialization of the composite began cellulose fibers plus phenolic resins, urea resins, melamine resins, and the most familiar composite material is the fiberglass, and understate the polyester plus glass matrix. And what is the reinforced polymers? High strength and the low weight uses of a polymer composites, automotive, marine, construction, electric and the electronics, aerospace and the military. And these are some example of the competition epoxy resins, thermo set polymers होते हैं, मैट्रिक्स लाइटनेस होती है, एक्सेलेंट corrosion रेजिस्टेंस होती है, इसमें वाटर के लिहाज से इकोनॉमिकल कंस्ट्रक्शन होती है स्मॉल बैचेस में, and the Kevlar primers plus carbon fibers, essential strength and the rigidity, very little cost in the extra weight and very fast and light is small bores. Performance is critical, low price, more importance, and glass fiber reinforced plastic, GRP, and the polyesters. What is the tensile required? Tennis requires basically nylon matrix plus carbon fiber, nylon 66 matrix, low density, economical construction by the injections, molding, and in large batches. Polymer is modulated around the low TM metal alloy. And similarly, rubber car tie reinforced at several different levels, at microwave level and the मैक्रोस्कोपिक लेवल. पहले हम माइक्रोस्कोपिक लेवल को देख लेते हैं. कार्बन ब्लैक मिक्स्ड विद द पॉलीमर इंक्रीज स्टिफनेस, स्ट्रेंथ एंड द वियर रेजिस्टेंस, एंड एट मैक्रोस्कोपिक लेवल रिजिड कॉर्ड्स, polyester fibers or steel wires to provide strength and stiffness in the radial and the circumferential direction. But its reinforcing agents have following abilities, and the functions must be stiffer and stronger than the polymer matrix. It has good particle size, shape, and the surface vector for the effective mechanical coupling to the matrix, and it preserves the desirable qualities of the polymer matrix. What is the mechanism of reinforcement, stress and strain, and in the presence of a reinforcement agent total strain in the matrix? Now, friends, the strength of the polymer composite depends upon the strength of the bond between the particle and the matrix. The more interface effective reinforcement, effectiveness of the reinforcement, AB ratio, and the surface area of a particle volume, and AB to as high as possible. And for acrylic, you can see here that this is the equation by the aspect ratio of the cylinder, and इसमें जो है वो सिलेंड्रिकल पार्टिकल्स की जो है वो रेशो बताई गई है कि A is equal to L divided by D, and equation has the A and B in the circular form 2 pi divided by B 1 over 3 A minus 2 by 3 plus 2 A 1 by 3. How it is formed, ये आई कहाँ से है? बेसिकली जो सिलेंड्रिकल पार्टिकल्स होते हैं उनकी ये रेशो होती है कि जो एग्जिस्ट कर रहे होते हैं इन द polymer. Here the A should be greater than 1, then ये fibers होंगे, and if smaller than 1, then ये platelets होंगे. Therefore, two main classes of a reinforcement agent is the fiber, glass fiber, carbon fibers, and the platelets, mica and the gel. But is the fiber in the matrix mass volume mf basically fiber की mass है, mm जो है वो matrix की mass है. assume कर ले there is no white, then m इनको plus करेंगे, volume को divide करेंगे तो volume ratio आएगी. volume ratio so you can find out the density of the fiber and density of the matrix. Similarly, in you can see in the other part, reinforced polymer generally have low densities, and epoxy reinforced with a 70% carbon fiber is only 1700 kilogram per meter cube, and the density water 1000 kg and per meter cube. ये था जनरल सा इंट्रोडक्शन. ना वाइंड अप इन प्रैक्टिस अगर हम देखें तो कंपोजिट मटेरियल्स जो होते हैं वो ट्रैप्ड करते हैं एयर को, सॉल्वेंट्स को, एंड अवॉइड द सोर्स ऑफ वीकनेस. वाइट कॉन्टेक्ट्स ग्रेटर देन 2% प्योर फैब्रिकेशन, एंड अ वाइट परसेंटेज 0.5% हाई क्लास aircraft quality is basically required for the fabrication. What is the polymer matrices? Initially thermoset polymers जो होते हैं वो थर्मोसेट पॉलीस्टर्स एंड इनएक्सपेंसिव पॉलीमर्स जो होते हैं जो कि ग्लास फाइबर्स रीइंफोर्समेंट में यूज होते हैं. एपॉक्सीज क्या होती हैं? प्रेफर टू पॉलीस्टर्स. मीडियम मैकेनिकल परफॉर्मेंस होती हैं लेकिन हायर कॉस्ट होती है देन द पॉलीस्टर्स. हम टुडेज जो है वो रीइंफोर्स थर्मोप्लास्टिक मटेरियल ज़्यादातर पॉपुलर है सेमी क्रिस्टलाइन पॉलीमर पीपी एंड द नायलॉन में. एंड मेजर एडवांटेज इसका क्या है? फॉर्मेज इज पॉसिबल बाय नॉर्मल इंजेक्शन, मोल्डिंग और एक्सट्रूशन. What is the fibrous reinforcement? Glass fibers होते हैं E class, S class. Orientation polymeric fibers, Aramid, Kevlar, and DuPont company, and the carbon fibers. What is the glass fiber? Is widely used on E class, silicon oxide, calcium oxide, aluminium oxide, boron oxide, magnesium oxide. Different percentage में S class में higher modulus strength होती है, C class जो होते हैं improved resistance to water and the acids. इनमें डिफरेंस जो है वो यहाँ पे क्लियर है कि आप ग्लास फाइबर जो होते हैं वो मैन्युफैक्चर होते हैं मोटे क्लास में एंड हाई लीनियर वेलोसिटी हुआ लार्ज नंबर ऑफ द फीचर्स. एडवांटेज है ग्लास फाइबर का? रेजिस्टेंस टू हाई टेम्परेचर, सॉफ्टनिंग पॉइंट इज 50 डिग्री सेंटीग्रेड, ट्रांसपेरेंसी जो है वो विजिबल लाइट होती है टेक्स करते हैं. कलर ऑफ द मैट्रिक्स, आइसोट्रॉपी जस्ट लाइक थर्मल एक्सपेंशन इज आइडेंटिकल इन द एक्चुअल एंड द रेडियल डायरेक्शन. डिसएडवांटेज है ससेप्टेबल टू द surface damage. Carbon and the Kevlar fibers are less widely used than glass fiber due to their relatively high cost, and the best carbon fibers जो होते हैं produce होते हैं from PAN, polychlornitrile. PAN is converted to graphite by the controlled heating and the process. What is the advantage of C fiber? Chemical inertness, resistance to moisture, and the common chemicals, high electrical and the thermal conductivity along the fiber axis, dimensional stability and the thermal expansion इसमें होती है low negative होती है. Disadvantage basically color इसका black होता है. What is the orientation of the polymer fiber? Aramid fibers होते हैं aromatic group and amide group due to the group order of excellence क्या है? कार्बन जिसमें होती है वो ज़्यादा होते हैं effective, and then aramid and then glass. What is the plateless reinforcement? टैल्क में जो है मैग्नीशियम ऑक्साइड, सिलिकॉन ऑक्साइड एंड वाटर होते हैं. माइका में एल्यूमिनियम होता है, सिलिकॉन होता है एंड पोटेशियम, एंड बेसिकली क्रिस्टलाइन होते हैं, नेचुरली अकरिंग मटेरियल होते हैं, एंड थिकनेस एंड प्राइस के लिहाज से ये लो होते हैं, और स्टिफनेस एंड स्ट्रेंथ जो है इसमें equally effective होती है. What is interfacial adhesion and the coupling agent? Coupling agent, low and molecular weight organic inorganic compounds that promote the adhesion between the pillar and the matrix. Generally organofunctional silenes होते हैं. Enduring thermoplastic peak में TM जो होती है 334 डिग्री सेंटीग्रेड पर होती है, 30% होता है जो फाइबर लोडिंग होती है. And what is the mechanical properties of a composites are strongly influenced by the size, type, concentration, dispersion, and reinforcement agent and the interfacial tension जो उनके दरमियान दरमियान होती है, मेट्रस एंड द पिलर के दरमियान. एंड व्हाट इज द कंपोजिट्स आर प्रोड्यूस्ड बाय a number of methods: compression molding, recent transfer molding, filament binding, and the pultrusion. Here is some filament binding operation. Here is the pultrusion line. And what is the nanocomposites? Is basically the research to develop first nanocomposite from the nylon 6 clay and nanopillars. Thickness जो होती है 1 nanometer होती है. Aspect ratio दिया हुआ है L में 10:1 होती है. And the commonly used clay nanopillar is the montmorillonite MFT naturally जो है occurring silicates होती है. And that's all. Here is the some phase separation, intercalated in the microcomposites, nanocomposites, and the similarly polymer and the layered silicons. Thank you very much. Any question?